solve and state any domain restrictions, presumably solve for x. So there's a couple things I can do here. Some people might immediately recognize that I could just multiply both sides by x squared minus 9 to clear the denominator. Now, of course, before I start canceling or dividing out things, I do need to determine my domain restrictions. This is the difference of two squares, x plus 3, x minus 3. So my domain restrictions, x cannot be 3 or negative 3. So now I'm ready. So simplifying. So this leaves me with x squared plus minus 2x minus 15 is equal to 3 times x squared minus 9. Well, I can of course distribute, so 3x squared minus 27 is equal to x squared minus 2x minus 15. I'm going to get all my values over to the right side so that I can, since I have a quadratic here, I can use quadratic formula or try to factor. Minus x squared plus 2x plus 15. So I'm left with 2x squared plus 2x plus 12 equals 0. So fortunately, I can factor this further. I can divide everything by 2. 0 divided by 2 is 0. So I have 0 equals x squared plus x plus 6. I think I can factor that. Things that multiply to 6 that add to 1. Sorry, multiply to negative 6, right? Because it's negative 27 plus 15. Negative 6. So that would be x plus 3, x minus 2. Because negative 2 and 3 multiply to negative 6 and add to 1. Which means my solutions here are x equals negative 3 and positive 2. But you'll notice it can't be negative 3 because of my restrictions. So that solution's out. The only solution that works is 2. So again, really important to find your domain restrictions, not just because I ask you to, but because they help you eliminate extraneous solutions. Now I want to show you another way of solving this problem that might have been simpler. Might have been a little easier to do, fewer steps, maybe less room for error, which is factor first. So let's factor. The top factors to x minus 5, x plus 3, because 3 and negative 5 are the numbers that multiply to negative 15 and add to negative 2. The bottom again, x minus 3, x plus 3, this equals 3. You can see now that x plus 3 divides out. Same domain restrictions, of course. So now I have x minus 5 over x minus 3 is equal to 3. And some people like to think of it this way as a cross multiplication problem. So x minus 5 is equal to 3 times x minus 3, which distributing the 3, 3x minus 9 is equal to x minus 5. And now this is a linear problem, right? Simpler than the quadratic. So I'm going to add 9 to both sides. I'm going to subtract my x from both sides to get the x's all on one side. So I have 2x equals 4 divided by 2, x equals 2. So you'll notice I didn't even get the extraneous solution there because I simplified first. And that doesn't always get rid of it, but it did in this case.